Today we're going to be simplifying radical expressions. And we've done something similar before when we would simplify square root expressions. You know, we had the square root of something like 72. And we broke that up into perfect squares to simplify that. Now we're going to be doing the same thing, but also with other types of roots. So if you look down here, and we have all these properties from before where you can break things up with multiplication or division. So if we look at our examples down here, what you'll notice is that they have different roots. So this is a third root. So like I was saying, the square root, you don't need to write this down right now. The square root of 72, we broke this up into 36 and 2 because 36 is a perfect square that we could take the square root of and make it a simplified radical. Well, if we're doing third roots, we want to use perfect cubes. Or for fourth roots, we want perfect fourths. So let's look at this right now. Can we take the cube root of any of these? Well, the cube root of 125 is 5, and the cube root of 8 is 2. So this will equal 10. In letter B, one of our rules is that you can write this under one radical, and then we can maybe simplify 96 divided by 3, and that gets us 32. So this can be rewritten as the third root of 32. Now can we break this up into a number that we could take the cube root of? Not the square root, because you might be thinking, oh, 16 and 2. If we were in square root land, that would be okay. But now we are in cube root land. So we want to divide this up into a perfect cube. We can do the cube root of 8 times the cube root of 4. The cube root of 8 is 2. And we can't take the cube root of 4, so this gets left. I want to point something out. Once you take the cube root of something, the radical symbol goes away. So here we had the cube root of 8. We can actually take the cube root of 8 and get 2, so the cube root symbol goes away. And then the cube root of 4, we can't do anything with that, so we just bring that down with the radical and everything. So this would be your final answer. Right, here we are in square root land. So see, can we do 245 divided by 5? We get the square root of 49, which we know is a perfect square, and we get 7. All right, now the third root of 432. And just like with square roots, if we don't know the biggest perfect cube that we can use, we can always start small. You could start with 8 if you wanted to. You could start with, let's do 8. Just so you can see the cube root of 8 and the cube root of 54. Well, the cube root of 8 is 2. Now, can we break up the cube root? Let me write that out. Can we break up the cube root of 54? Let's see. The 54 divided by 8. Nope, can't do that. 54 divided by the next biggest perfect cube will be 27, and we can do that. The cube root of 27 times the cube root of 2. The cube root of 27 is 3. times the cube root of 2. And then we can multiply 2 times 3 and get 6. So our answer is 6 times the cube root of 2. Now, like I was saying, you could have done something different up here instead of doing what we did here. We could have done 432 divided by 216, because 216 is 6 cubed. And then this would be 6 times the cube root of 2. So we get the same answer if we don't use the biggest perfect cube. You know, that's why I've been saying if you're unsure, always start small and then you can keep going. Letter E, the cube root of 104. So 104, can we divide that by 4? We can. Or sorry, not 4, 8. And we get 13. The cube root of 8 is 2. And we can't simplify the cube root of 13, so this is our final answer. Now here we have the square root of 10 over the square root of 27. Now if we were to write this as one square root, and I'm going to have to erase this in a minute, we can't simplify that. 10 divided by 27 is not a whole number. So we're going to have to multiply the top and bottom by the square root of 27. And the reason for that is because we can't have a square root in the denominator. Up here, we were able to simplify this, and that's why we didn't have to multiply the top and bottom by the square root of 5. Here we can't simplify, so then we're going to have to do this. So this is going to give us the square root of 270 over 27. Now, can we break up 270 into perfect squares? We can divide that by 9. The square root of 9 is 3. So we have 3 times the square root of 30 over 27. Now, can we break up the square root of 30? We can't, so we leave that one alone. But we can simplify 3 over 27, and that's going to give us the square root of 30 over 9. So now let's look at the next page here. We got 2 more. The fourth root. So the fourth root of 32, we can break this up into the fourth root of 16 times the fourth root of 2 times the fourth root of 8. Well, the fourth root of 16 is 2. And we can multiply those because they're both the same root. They're both fourth roots. So that becomes a fourth root of 8 times 2 is 16. Well, we know what the fourth root of 16 is. We just said that. So we're going to bring this 2 down times the fourth root of 16 is also 2. So our answer is 4. Now you could have also multiplied 32 and 8 at the very beginning. 32 times 8 would have been the fourth root of 256. But I don't know what the fourth root of 256 is off the top of my head. So that's why I approached it this way. Now the last one over here, we could multiply these numbers out, or we could break them up. I want to break this up first because the directions say without a calculator. So I'm going to make things simpler first and then combine things. This is going to be the third root of 8 times the third root of 4 times negative 2 times the third root of 4. So we're going to have 3 times the third root of 8 is 2 times the third root of 4 times negative 2 times the third root of 4. So since this is multiplying, we can multiply all our numbers. And remember, we can only multiply the numbers outside the radicals together and the numbers inside the radicals together. We can't do inside and outside. So 3 times 2 times negative 2 is going to be negative 12 times the third root of 4 times 4 is 16. Well, we can break up 16 into the third root of 8 times the third root of 2. So negative 12 times the third root of 8 is 2. Negative 12 times 2 is negative 24. And then the third root of 2 will just come down and be there. So yeah, this one required a little bit of work, and this is not the only way that this could have been done. It was just so this way was the easiest for me without using a calculator. Now, adding and subtracting radicals, that's where things get a little bit more difficult because we have to make sure our radicals have the same index and the same radicand, or the stuff underneath the radical has to be the same. So in letter A, they both are third roots, and they're both the third root of 12, so we can just combine like terms. You could think of this as 7x minus 1x would be 6x. Well, we have 7 times the cube root of 12 minus the cube root of 12. So that's going to be 6 times the cube root of 12. And that would be our answer because we can't break up the cube root of 12 into any perfect cubes. So that would be where we stop. Letter B, all right, they're both third roots, but we have different things underneath the radical. So what we want to do is break these up into perfect cubes. We can break 81 up into the third root of 27 times the third root of 3. And we can break up 24 into the third root of 8 times the third root of 3. Because 8 times 3 is 24. Now the third root of 27 is 3. So this becomes 3 times the third root of 3 minus the third root of 8 is 2. So we have 8 times the third root of 3. Now our radicals are the same. They're both the third root of 3. So 3 third root of 3 minus 2 times the third root of 3 is going to equal 1 times the third root of 3. And you don't need that 1 in front, so it just becomes the third root of 3. All right, now letter C, we need to change this into a radical. That would probably make things a little bit easier. So we have 4. And remember, when we switch from a rational exponent to radical form, the bottom number, the denominator, is your root. So this is going to be the third root of 2 squared plus 8 times the third root of 2 squared. Well, we know 2 squared is 4. So this is going to be 4 times the third root of 4 plus 8 times the third root of 4. We can't take the third root of 4, so this is going to be 12 times the third root of 4. Now down here, these are square roots, so we want to try to break these up into perfect squares. We can't add them because they're different radicals. We have the square root of 45 and the square root of 20. We have a 3 out front, but we can break up 45 into 9 times 5 plus 7, and we can break up 20 into 4 times 5 because the square root of 4 is 2. So we have 3 times the square root of 9 is 3 times the square root of 5 plus 7 times the square root of 4 is 2 times the square root of 5. So we have 9 times the square root of 5 plus 14 times the square root of 5, which equals 23 times the square root of 5. And since we can't simplify the square root of 5, that is our answer. Okay. We are now looking at cube roots because of the 3 right here. We can break up 16 into the cube root of 8 times the cube root of 2. And then we can break up 54, so minus the cube root of 54 is 27 times 2. 2 times the cube root of 8 is 2. Minus the third root of 27 is 3, or the cube root of 27 is 3, times the third root of 2. 2 times 2 is 4, so we have 4 times the third root of 2 minus 3 times the third root of 2, and that's going to be 1 times the third root of 2. And just like before, we don't need that number 1. So we have the third root of 2. So knowing your perfect cubes and squares is super important to simplifying these radicals. Remember, you cannot add the stuff underneath the square roots. You could multiply. If these were multiplication problems, then we wouldn't need to do this, breaking up the radicals into square roots or cube roots. But because we are adding or subtracting, we must make sure that our radicals are the same. So the more we do these, the better you'll get at them. And again, recognizing your perfect squares and your perfect cubes definitely makes this easier. So thanks for watching. Make sure to like and subscribe.